So I want to go through here, I want to talk a little bit about alkanes. We're going to use ethane as our example. But in general, the bonding on the alkane is very strong, and there are not a lot of spots where you see any polarization. So you're not seeing a collection of negative or positive charge, you're quite neutral just about everywhere. And so other molecules that come along, whether they're electrophiles or whether they're nucleophiles, are really not going to interact much with this, and you're not going to see a lot of reaction. Okay, so if I want them to react, I mean obviously I can burn them. Okay, so the burning with the very reactive oxygen, and that involves a spark usually to get that going. That's going to obviously oxidize this, and that's going to be a chemical reaction. But if I wanted to get to react with something else, there usually needs to be another kind of spark, so to speak, with that as well. And what we tend to use is ultraviolet light. So ultraviolet light has the ability to separate apart these bonds, and it forms what are called free radicals. So let's say that this ultraviolet light is put on a mixture of bromine and ethane, and one of those light waves splits apart that bond, and let's say one electron from each goes to each bromine. So what I'll end up with is I'll have a bromine atom, and then I'll have another bromine atom that's been cleaved by the ultraviolet light, and this is called a free radical. And if we think about bromine for a second, it's in the 4p5 for electron configuration. So one of its p electrons is unpaired, and that's what a free radical is. And having that unpaired electron tends to make these find another electron. And that's a combination of protons, of course, and shielding electrons like we've seen before. But basically, this is going to react with something else. And so what can happen then is if I take my ethane and it collides with one of these free radicals, I'm going to form some new bonds. And so what can happen here is quite simply, this electron from this hydrogen can form a bond with the bromine, forming HBr. But then this electron will stay here with the carbon. That's the worst arrow I've ever seen in my life. Let's try that again. No, it's still not very good. How about from here? There we go. So what I'll have is I'll have a new free radical. And in this case, it'll be an ethyl radical. And the way we usually draw that is we just put a dot there to indicate that there's that lone unpaired electron on it. So now my ethyl group is very reactive, and so now I can get this to react with something. If I have this other bromine atom around, of course that would react with it, and that would be great because that would end this whole process. Usually that might not happen, and this will cause another radical to form, and that process will kind of repeat. But these two things can form a bond, and I can end up with an alkyl halide. And so here I would have bromoethane. So this is the way you could get an alkane to react, is through UV light. Most of the other chemicals we're going to look at in organic chemistry are going to have sites where they have an electron deficiency or an excess of electrons, and those are going to lead to chemical reactions happening with the opposite. So when this doesn't occur, that's when I would need to bring in something else to induce this reaction to get it to happen. But if I want to make something like this, that's one of the ways that I could do that. Okay? As far as the IB stuff goes, you want to know that anytime you see a dot like this, that's telling you you have a free radical. And that this free radical is going to react with something else as soon as it can, until it's not a free radical, but that process is probably going to leave that next thing also a free radical. At some point, when you get two free radicals to meet, that's when the end of that occurs. And so that's the danger in the ozone layer, of course, when you have these chlorine free radicals going around and reacting with a lot of ozone and reducing the amount of that. And then also in food, if you've heard of antioxidants, those are things that have an electron that they're able to donate to a free radical to end that kind of repeating stages of free radicals forming.